Check one. Check one. Hari. Hello, everybody. Today is the second day of waves lesson. The interactive class. Today is the second day of waves lesson. Already we have finished the day one. Until physical quantities associated with waves, we have done. So today we'll have to continue from that section. To the YouTube people, in case if you are watching this video, there is already day one video of waves interactive class. Please watch that and then come to this. If you are watching live now, no problem. Watch this video and finish off. After that, you can watch that. Okay, then before we start, tell me, is all the duos perfect? Dingal, send me a message. Video, audio, all okay. Perfect. Okay, no? All okay, right. Without any further delay, we'll start. Then on the way, I'll talk to you all. Still, I didn't switch on the unmute feature. So after you get a little bit on the beat, I'll allow you all to unmute. Okay. Waves and the application. Can remember what is wave? What is wave? A disturbance that propagates energy from one place to another. Tell me, during a wave propagation, does particle propagate? Does particle propagate? Yes or no? During wave propagation, does particle move? Is there a full propagation of the particle? No, there's no total propagation. Waves are divided into two: mechanical wave, electromagnetic wave. Now these things, ding, 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 all should come to the mind. Mechanical waves, electromagnetic waves. Mechanical wave require a medium. Electromagnetic wave do not require a medium. Mechanical wave divided into the transverse wave, longitudinal wave. Transverse wave, what's the keyword? Perpendicular. What is perpendicular? Particle motion is perpendicular to the wave propagation. Longitudinal wave, what's the keyword? Parallel. What is parallel to what? Particle motion is parallel to the wave motion. And then we went through the physical quantities associated with wave motion. Physical quantities associated with wave. We'll revise. We'll revise. I'll allow you all to unmute. Also don't feel it. Wait a minute. I'll open the unmute feature. Right. On. Tell me. Wave. I'll draw displacement versus time. In a wave, maximum displacement of the particle is
amplitude.
Amplitude. Perfect. Amplitude. Maximum displacement of the particle, amplitude. 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 This is one single wave. That is one single wave. Maximum point in a wave?
Crest.
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 Minimum point in a wave?
Trough.
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 Graph.
Graph.
Draft.
This is distance versus graph. Time. Time taken for one full oscillation. Time taken for one full oscillation. Time,
Period.
time for one
Period.
oscillation. Time for
Period.
one wave is
Period.
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 period, symbolized as capital T. Time for one wave is period, symbolized as capital T. In a displacement distance graph, displacement distance graph is distance. Same story, this is amplitude, crest, trough. Y'all tell me. Length of one wave. Length of one wave is
Wavelength.
Lambda.
Wavelength. Wavelength.
symbolized as lambda. Symbolized as lambda, Greek symbol. Lambda is wavelength. That's wavelength. And period is time taken for one full wave, one full oscillation, right? Other than that, we define something called frequency. Frequency? What's frequency?
Number of oscillation in a unit time.
Oscillations in a unit time. How many waves are there in a unit time? Unit time means in 1 second. How many waves are there? Number of oscillations in unit time. In 1 second, how many oscillations are there? How many waves are there? The unit.
Hertz.
Hertz. H is a
Hertz.
symbol is
Hertz.
H is a Hertz is the
Seconds.
SI unit.
Or per second.
Relationship between frequency and period. Who can remember?
Opposite of speed.
Reciprocal.
Inverse
Reciprocal. Frequency is 1 over period. Frequency is 1 over period. Frequency is reciprocal of period. And finally, I get the equation for speed. Speed of a wave. Speed of a wave. How to calculate the speed of a wave? What's the equation?
Into lambda.
F into lambda.
V equal F lambda. F is the frequency. Lambda is the
Lambda.
wavelength. Frequency multiplied by wavelength gives you the speed of the wave. Frequency multiplied by wavelength gives you the speed. If there are any new students, now listen. You can calculate the speed of a wave by multiplying frequency of the wave by its wavelength. Frequency of the wave multiplied by the wavelength gives you the speed. We'll do some questions from this. Take your writing book, or otherwise now what physical students did was, in the tute there were some free blanks at the end. No, you all don't have the tute, no? So better take a separate paper or your normal writing book. Write down questions. Write down questions. Write down questions. Right. Question number 1. Question number 1. Calculate the speed of a wave listen and write. Calculate the speed of a wave with a frequency of hertz frequency of 10 hertz and a wavelength of 2 meters. Frequency 10 hertz, wavelength 2 meters. With a frequency of 10 hertz and wavelength 2 meters. Leave about 3 lines. Leave about 3 lines. Question 2. Question 2. Calculate the speed of a sound wave. 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 With a frequency of 30 hertz 30 hertz 30 hertz and wavelength of 2.5 meters. 2.5 meters on a decimal sign. 2.5 meters. Leave about 3 lines. Third question. Third question. Calculate the speed of a wave. Calculate the speed of a wave. Calculate the speed of a wave that is emitted. That is emitted. That is emitted with a frequency of 50 hertz 50 hertz 50 hertz and a wavelength of 100 centimeters. 100 centimeters. 100 centimeters. Remember, when doing physics question, all your in SI unit. Now tell me, wavelength, length. What's the unit of
Meters.
meters?
Me-
So if they give it centimeters, meters, to meter and do the question. They will give in go to meters. Fourth question. Fourth question. Uh, calculate the calculate the calculate the frequency of a sound wave Calculate the frequency of a sound wave. Calculate the frequency of sound wave. Propagating at a speed of 330 meters per second. Propagating at a speed of 330 meters per second. 330 meters per second. With a wavelength of 11 meters. Wavelength of 11 meters. Wavelength of 11 meters. Huh. Question 5. Question 5. Calculate the wavelength. Calculate the wavelength. Calculate the wavelength of a wave. Of a wave. Of a wave. That is proper speed of. That is propagating at a speed of. That is propagating at a speed of 500 meters per second. 500 meters per second. 500 meters per second. 500 meters per second. With a frequency of 1000 hertz. 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 Last question. Calculate the speed of a wave. Calculate the speed of a wave. Calculate the speed of a wave. With a period of 2 seconds. 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 And wavelength of 8 meters. And with a period of 2 seconds. And wavelength of. And wavelength of. Wavelength of. Wavelength of 80 centimeters. With a wavelength of 80 centimeters. Wavelength of 80 centimeters. Period 2 seconds, wavelength 80 centimeters. So remember, if they give in centimeters, convert to meters. Fifth question. Speed of the wave is 500 meters per second. Frequency is 1000 hertz. The person asked the fifth question. Speed of the wave 500 meters per second. Frequency 1000 hertz. You have to calculate the wavelength. Calculate the wavelength. Huh. First question I will do. See how I do. Pen don't go to do. First question I'll do and show you all. See how I do. First look. First, look and listen. First question, read the first question. Frequency of the wave is given 10 hertz. Wavelength is given 2 meters. They are asking the speed of the wave. We'll apply the equation. V equal F lambda. V equals F lambda. F is given 10 hertz. Multiplied by lambda. Wavelength is given 2 meters. Wavelength is given 2 meters. 10 multiplied by 2. 10 into 2, 20. Speed. Tell me what's the unit for speed? What's the SI unit of speed?
Meters per second.
Meters per second. Answer comes in meters per second. Now some of you will ask me, sir, how come the answer comes in meters per second? This is hertz, this is meter. How come the answer comes in meters per second? Lamai, can you all remember? I taught you all another unit for frequency. What's the other unit for frequency?
Per second.
Per second, sir.
Per second.
S to the power minus 1. Neither. So if I write the frequency in S to the power minus 1, speed becomes 10 S to the power minus 1 multiplied by 2 meters. Why? 10 S to the power minus 1. Hertz is S to the power minus 1. Hertz is S to the power minus 1. 10 into 2, 20. Meters is there. S to the power minus 1 is there. 20 meters per second. That's how that unit comes. So hertz means S to the power minus 1. Hertz means S to the power minus 1. Hertz is S to the power minus 1. That S to the power minus 1 will come here. Meters will come here. Meters per second. Speed will come in meters per second. You can't change the unit. Speed is meters per second. That is grade 10 physics. Speed is meters per second. Do the first question and do the remaining 5 questions. Altogether 6 questions. Keep in mind, centimeter should be converted to meters. Work. Once done, tell me done and send me the answers in order. First answer, second answer, third answer, send me. Work. Right. Most of you have sent the answers. I'll do the second question. You can correct your answers. I'll do the second question. Those who have got struck, please listen. Others, you all do and go, check and correct. Right. Second question. Frequency 30 Hz. Length is given 2.5 meters. What are they asking? They're asking the speed. Nothing big. Apply the equation. V equal F lambda. F is given 30 Hertz. Lambda. Wavelength is given 2.5 meters. Some fellows are scared when they see the decimal. No, you should solve it. Now you're like grade 11. 30 into 2.5. 30 into 2, 60. Half of 30 is 15. 60 plus 15, 75 meters per second. 75 meters per second. Right. Question number 3. Question number 3. Frequency is given. Wavelength is given, but wavelength is given in centimeters. Wavelength is given in centimeters, 100 centimeters. You all tell me 100 centimeters. How many meters?
1 meter.
100
Point
centimeter,
1.
1 meter.
Divide, sorry, 1.1. Divide by 100. You divide by 100, 1 meter. 100 centimeter is 1 meter. Frequency given, wavelength given, frequency given, wavelength given. They are asking the speed. Speed V is equal to F lambda. F is there 50 Hertz multiplied by lambda is there 1 meter. 50 into 1 meter, 50. 50 meters per second. Simple answers. Right. Question number 4. Speed of wave is given 330 meters per second. Wavelength is given 11 meters. Now what are they asking? The frequency. All this time they gave frequency, they gave wavelength, they asked speed. Now speed is given, wavelength is given, frequency is asked. Don't panic. Equation is same. V equal F lambda. What are the things given? Speed is given. Wavelength given. Lambda given. Frequency not given. You need to find frequency. If you need to find frequency, you have to subject frequency. If you subject frequency, lambda goes to the other side. Y'all tell me, lambda on other side, multiplication on other side, because
Division.
division. So frequency is speed divided by wavelength. Simple mathematical operation. I took this to the other side. On other side become division. F equal V over lambda. V is there 330 meters per second divided by lambda value is there 11 meters. When you do the math there, frequency is nicely this get cancelled off. 11 and 33 get cancelled off 3 times. That 0 is remaining 30 Hertz. Okay. Right. Question number 5. Here, speed of the wave is given, frequency given. They are asking the wavelength. Speed given, frequency given. They are asking the wavelength. Again, don't panic. Same equation. Speed V equal F lambda. What is given? Speed of the wave V is given. Frequency given, F is given. Lambda, wavelength not given, you need to find wavelength. If you need to find wavelength, you have to subject wavelength. If you subject wavelength, F goes to the other side. Tell me, F on the other side, multiplication on the other side. Again, it becomes what?
Division. Division.
Division.
So wavelength is V divided by F. Nothing big, I took F to the other side. V with their velocity is there 500 meters per second divided by F value. Frequency is there 1000 hertz. 500 divided by 1000. 500 divided by 1000 is half.
11.5.
Don't keep it as fractions. Don't keep it as fractions. Try to always keep as decimals. Half is 0.5. 0.5 meters. Wavelength will come in meters. Check whether you have written the unit. No unit, no marks. Wavelength will come in meters. 0.5 meters. Right. Final question. Those who did this question, send me the answer. Right, Nihansa, correct? Anudhi Abhimashi, correct? Zuha, correct? Za, correct? Dilakshan, correct? Fatima, correct? Getmika, correct? Umar, correct? Now think. Now, grade 11, you have to think a little bit. Sometimes directly what is there in the textbook or what is taught won't come. You have to think a little bit. Make connections. Now see, question 6. See whether you thought like this. Period is given. Period of the wave is 2 seconds. Wavelength is given in centimeters. Now there also we have a problem. Wavelength is given in centimeter. One shot will convert it. Tell me 80 centimeter. How many meters?
0.8 meter.
You have to divide by 100. 0.8 meters. Period given. Wavelength given. They are asking the speed. Now what's the equation we have for speed? Speed is equal to F lambda. That's the equation I taught for speed of the wave. No, that's the one and only equation we have for speed of the wave. V equal F lambda. They have given lambda value directly. Wavelength is directly given. Is frequency directly given? No. Frequency of the wave is not directly given the data. Frequency is missing. If you know the frequency, you can multiply, get the answer. Frequency is missing. So before you apply this equation, you should first find the frequency. That part you have to think. That's how you build your brain capacity. Slowly you build your brain such that when you get a question, you think in different routes and find out what to be found to solve this. V equal f lambda. Lambda is directly given. F is not given. Frequency not given. So your first job is you need to find frequency. Now again look at the data. Do we have anything that can be used to find the frequency?
Period.
Period is given. Tell me, what's the relationship between frequency and period? Today also we
Frequency
discussed.
is equal
F is equal 1 over t.
reciprocal of
1 over
Ah,
t.
1 over t.
very good. Frequency is 1 over period. Frequency is the reciprocal of period. F is equal to 1 over period. When you apply that equation, you can find the frequency. If you know frequency, you apply it here, you can find the speed. We'll work it out. We'll work it out. Frequency is 1 over period. 1 over period is given 2 seconds. 1 over 2 seconds is how much? 1 over 2. 1 over 2 is half. Neither. Half, if I put it in decimal, 0.5. 0.5 hertz. That's the frequency. Understood how I found the frequency first?
Yes.
Yes, sir.
Frequency is 1 over period. Period is given 2 seconds. So 1 over 2 is the frequency. Now we know the frequency. Now we think Jujupi Vadailamai. Frequency, you know, wavelength, you know, apply the equation. V equal f lambda. F is 0.5 hertz. Wavelength in meters, 0.8 meters. Now maths. Half of 0.8. Half of 0.8 is 0.4 meters per second.
Excuse me, sir. I have a doubt.
Yes, I'll come to the doubt. Yeah. Yes, Buddha. What's the doubt?
Sir, can we use this equation V equals lambda over period for this question?
That's the same thing I have done.
Lam-
Instead of f, you are telling you put 1 over t, isn't it? Instead of f, you put 1 over t. So when you put 1 over t, she has rearranged the equation and told lambda over t. So one shot you do the question. No problem, you can do. I do it in 2 steps so that you all can understand properly. Okay, you can do it in 1 shot. V equal lambda over t. That's the same thing I have done. V equal
Okay.
lambda over t. Same answer will come. Understood?
Excuse me, sir. Excuse me, sir.
Yeah.
Sir, can we use fractions for this instead of decimals?
Okay, you mean the final answer?
Yes, sir. And the calculation part also.
Right. Calculations you can do in fractions, no problem. But don't leave final answers in decimal because decimal is not a final answer mathematically. Sorry, fraction is not a final answer mathematically. Fraction means what? Now 4 over 2. What does this fraction means? 4 is divided by 2. That's the meaning. So don't leave the answer as fraction. Always leave it as decimal. Decimal gives us a final answer. Decimal takes us to a final answer. Fraction means further you can do some mathematical operation. Decimal, it's done. Okay.
Okay, sir.
Sir,
Yes.
Is 0.40 wrong?
Sorry?
0.40 wrong?
0.4. Yeah, no problem. It's the same. Why, how many
Yes.
zeros you put after the decimal? It doesn't count. No, Putta? Okay, no? Right. With that, physical quantities associated with wave motion is done. That's it, the physical quantities we have, and the calculation part we have. All the physical quantities associated with wave motion are done. We'll go back to the tube. So last week we stopped with this equation. Speed of wave V equal F lambda equation. V equal F lambda equation. With that, mechanical wave section is also fully done. Transverse wave, longitudinal wave, physical quantities, mechanical wave section is fully done. We have another type of wave. What is that? Electromagnetic wave. Electromagnetic wave. On new section. Electromagnetic wave. You all tell me. Requires a medium or do not require a medium? Requires a medium or do not requires a medium?
Do not
Do not require medium. Do not require a medium.
Do not require a medium. Electromagnetic do not require a medium. So electromagnetic wave, remember, it doesn't need a medium. Without a medium, it can propagate. Even if there is a medium, no problem. Still, it can propagate. Electromagnetic medium, electromagnetic wave, they do not require a medium. Even if there's a medium, still no problem. It propagates. What's the correct definition of electromagnetic wave? How do you scientifically define electromagnetic wave? I'll tell the definition. Initially, you won't understand. Later on, when I draw and show you all only, you will understand. So first, listen. What is electromagnetic wave? Listen. Do oscillation of electromagnetic and magnetic wave that propagate perpendicular to each other is electromagnetic wave. You want to understand? First, listen. What is electromagnetic wave? Dual synchronized oscillation of electrical and magnetic wave that propagate perpendicular to each other. That means, I will break it phrase by phrase and explain you all. Right. What is electromagnetic wave? Listen. Heading itself tells us electromagnetic. Electromagnetic. It has two types of waves in it. It has electrical wave, and magnetic wave. And magnetic wave. Electrical wave is there, magnetic wave is there. Both of them together forms electromagnetic wave. How are they joining? How these electrical wave and magnetic wave are joining? I will draw and show you all. We'll take in this graph, y-axis is going to be electrical wave. We'll take the y-axis, vertical axis as electrical wave. x-axis, this axis, that I am going to take as direction of propagation. Direction in which wave is going to propagate. That's the direction of propagation. Then where is magnetic wave going to be? Magnetic wave is going to come out of the board and go into the board. It's propagating in this kind of an axis, in an axis that comes out of the board and into the board. Now, until now in maths, you have only learned two axes, no? Y-axis and x-axis. Only two axes you have, y-axis and x. Other than these two axes, Lamai, there is one more axis that comes out of the board and goes into the board. Axis like that. A axis that comes out of the board and goes into the board. That axis is called z-axis. Z-axis. The axis that comes out of the board and into the board. Now, can I draw this? Now, can I draw it like this? No, I can't draw. As I can't draw like this, what we do is, we draw it like this. That z-axis, we draw it like this. Actually speaking, that is the shadow of this axis. See, z-axis is coming out and going in. That one's shadow I have drawn there. Z-axis shadow I have drawn there. This axis is actually coming out of the board, going into the board. Y-axis, x-axis, z-axis. This z-axis is going to be my magnetic wave. Electrical wave is there. Magnetic wave is there, coming out of the board and going into the board. And direction is there. Look at these three. Can you see all these three are perpendicular to each other? Electrical wave perpendicular to the direction. Electrical wave perpendicular to magnetic wave. Magnetic wave perpendicular to the direction. If I show you all, it's something like this. I'll use this black marker pen as the electrical wave. This is the axis of electrical wave. I'll use this blue marker pen to represent the axis of direction. This is the direction in which wave is going to propagate. Z-axis, its axis like this. Its axis like this. See, coming out of the board and going into the board. Electrical wave, magnetic wave, direction. Can you see electrical wave axis is perpendicular to the direction? And electrical wave axis is perpendicular to magnetic wave. And magnetic wave perpendicular to the direction. Can you see all three are perpendicular to each other? All three are perpendicular to each other. That is how these three axes are arranged. Now, until now in math, you have only learned two axes. You have only learned two axes. That's only x and y axis. Now, this is the other axis, z axis. Electrical, magnetic, direction. I'll draw the graph and show you all now. I'll draw the graph and show you all. See, electrical wave. Electrical wave is propagating on this axis. On this axis, vertical axis, electrical wave is going. On this vertical axis, electrical wave is going. I'll use red color for magnetic wave. On this axis, out and into the boot. Out and into the boot, magnetic wave. Look. I'll color them. This is electrical wave on y-axis. That's electrical wave on y-axis. This is magnetic wave on x-axis. Slightly blur your eye. Slightly blur your eye and can you see a 3D diagram? Can you see electrical wave is going in a vertical plane like this? Magnetic wave is going in a horizontal plane like this. Can you see that? Slightly blur your eye and electrical wave on a vertical plane like this. Magnetic wave on a horizontal plane like this. And can you see both are perpendicular? Electrical wave like this, magnetic wave like this. So both are perpendicular. See, electrical wave like this, magnetic wave like this. Electrical wave like this, magnetic wave like this. Electrical like this. Now down like this, magnetic like this. Blur the eye. See, get the idea into the mind. Okay, so both are perpendicular to each other. Even their direction is perpendicular to both of them. Even their direction is perpendicular to both of them. This is how electromagnetic waves propagate. Now I'll tell the definition. Dual synchronized oscillation. What is dual synchronized oscillation? Dual waves are there. Dual, two waves. Both those waves are synchronized together. Synchronized together. Synchronized. Synchronized. What is syncing? SYNC. Sync. What is sync means? Not the kitchen sink. SYNC sync. When two things or more than two things go together, we tell they are going in a syncing way. Songs, the vocals should sync with the music there. Sometimes have you all seen? Some people they play the karaoke. Music is going in one side. They are singing on another side. They both are syncing. We tell music is not syncing with voice. Have you come across that word? Music not syncing with the voice. So syncing means something like merging and going. If you look at electromagnetic wave, can you see nicely electrical wave and magnetic wave are syncing and going nicely. They are syncing. See, electrical wave is coming here. Meanwhile, magnetic wave is also coming there, syncing. Electrical wave here, magnetic wave here, again syncing. Electrical wave there, magnetic wave there, nicely there. I have nicely synced and drawn it. Now, did I draw it like this? Electrical wave on, that is magnetic wave. If I draw like this, it is not syncing. It's not properly syncing. This is not syncing. See, this is not syncing. Here, syncing. So it's dual synchronized. two things are synchronized together. Oscillation of, these are oscillating, oscillation of electrical and magnetic wave. Again, I repeat, dual synchronized oscillation of electrical and magnetic wave that propagate perpendicular to each other is electromagnetic wave. Dual synchronized oscillation of electrical and magnetic wave that propagate perpendicular to each other. Electromagnetic wave. Okay. You don't actually need the definition, but it's more easier if you can understand this definition. Dual synchronized oscillation. Then you can understand how this electromagnetic wave is. Dual synchronized oscillation of electrical and magnetic wave that are propagating perpendicular to each other is electromagnetic wave. Okay. In your tute, under electromagnetic wave, we'll write down. Under electromagnetic wave, write down. Dual synchronized. I'll write the spelling for synchronized. Dual synchronized oscillation of electrical and magnetic wave that propagate perpendicular to each other. Perpendicular to each other. Is electromagnetic wave. Is electromagnetic wave. Is electromagnetic wave. Another nice picture is given depicting electromagnetic wave. Next, characteristics of electromagnetic wave. Characteristics of electromagnetic wave. What are the characteristics of electromagnetic wave? There are three characteristics of electromagnetic wave. There are three characteristics of electromagnetic wave. Number one, electromagnetic wave do not require a medium to propagate. You don't need a medium. Medium is not a requirement. On do not require a medium. Do not require a medium to propagate. Their speed in vacuum. Their speed in vacuum is 3 into 10 to the power 8 meters per second. What is the speed of electromagnetic wave in vacuum? 3 into 10 to the power 8 meters per second. 3 into 10 to the power 8 meters per second. What does 3 into 10 to the power 8 meters per second means? 3, 1, 2, 3, 4, 5, 6, 7, 8 meters per second. This is the speed of electromagnetic wave in vacuum. That is 300 million. So it's not thousands or millions, on 300 million meters per second. 3 into 10 to the power meters per second. That's the speed of electromagnetic wave in vacuum, in space, free space. Final point. Remember, remember, electromagnetic wave is not affected by, not affected by external electrical and magnetic waves. It is not affected by external electrical and magnetic wave. It's not affected by external electrical and magnetic wave. That means, now usually if you have a magnetic wave, what is magnetic wave means? Around a magnet, you have magnetic wave. You also call it magnetic field. Around a magnet, you have magnetic wave, magnetic field, north, south. This has a magnetic field. Let's take, I bring another magnet closer. I bring another magnet closer. It also has magnetic field. When I bring another magnet closer to this magnet, what will happen? These two magnets get attracted. Why they get attracted? Because these magnetic fields are going to get attracted. This magnetic field is affecting this magnetic field. That is why it is getting attracted. This magnetic field is affecting this magnetic field. This field is pulling this field. That's why they get attracted. So magnetic field, there is a effect between them. Either it's attraction or repulsion. If you bring south here, repulsion is there. So one magnetic field will influence another magnetic field. Now look at electromagnetic wave. Electromagnetic wave, it has magnetic wave. Now this red color one is magnetic wave. If I bring another magnet closer, that magnet also has magnetic field. This is having magnetic field. This is also having magnetic field. But still, is this magnetic field affected by this external magnetic field? No. Magnetic field in electromagnetic wave is not affected by external magnetic field. Usually, if two magnetic fields are brought closer, one magnetic field will affect the other magnetic field. But in electromagnetic wave, even though you have magnetic field, red color one is magnetic field, even though you have magnetic field, that magnetic field is affected by external magnetic field. Same with electrical wave. This electrical wave is not affected by any external electrical wave. A certain electrical wave will affect the other electrical wave. It can bend them. That won't happen here. External electrical wave cannot affect the electrical wave in electromagnetic. So remember, electromagnetic waves are not affected by external electrical and external magnetic waves. Again, I repeat, electromagnetic waves are not affected by external electrical and external magnetic waves. They are not affected. That's a very important characteristic. Not affected. So those are the three characteristics of electromagnetic wave. Take the characteristic section. Electromagnetic waves are not affected by external electromagnetic field. Underline or highlight it. It's a very important characteristic. They do not require a material medium for propagation, that we already know. They travel at a speed of 3 into 10 to the power 8 meters per second in vacuum. Memorize this number, very important number. 3 into 10 to the power 8 meters per second in vacuum. 3 into 10 to the power 8 meters per second in vacuum. Huh. Next section. Those are the characteristics. Next section. New section. Electromagnetic spectrum. We open the mouth and pronounce the name. Electromagnetic spectrum. Electromagnetic spectrum. What is electromagnetic spectrum? A spectrum that consists of all the possible frequencies and wavelengths in electromagnetic waves. Again, listen. What is electromagnetic spectrum? A spectrum that consists of all the possible frequencies and wavelength in electromagnetic wave. In electromagnetic wave, all the frequencies and wavelength together is electromagnetic spectrum. You won't understand now. After I draw the spectrum only, you will understand. I'll draw the spectrum. In electromagnetic spectrum, all the electromagnetic waves are there. All the frequencies and the wavelengths are there. All the electromagnetic waves are there. What are the electromagnetic waves we have? Onnabuta. Open the mouth and tell louder. When I write it together with me, tell louder. Starting off with gamma rays. Gamma rays. Open the mouth and tell louder. Gamma rays. After gamma rays, next you have X-rays. What rays? X-rays. After X-rays, next you have ultraviolet radiation. Ultraviolet radiation, also called as UV. UV. After UV, you have visible light. After UV, visible light. After the visible light, next you have infrared radiation. Infrared radiation. After infrared radiation, next we have microwave. Finally, radio wave. Finally, radio wave. Open the mouth and tell me the electromagnetic spectrum. Gamma rays, X-rays, ultraviolet radiation, visible light, infrared radiation, also called IR, microwave, radio wave. Again, this order is very important. Gamma rays, X-rays, ultraviolet radiation. Center is visible light. Infrared radiation, microwave, radio wave. Again, gamma rays, X-rays, ultraviolet radiation. Center is visible light. Infrared radiation, microwave, radio wave. One more time, open the mouth and tell louder. Now you memorize, put the things to the mind. Gamma rays, X-rays, ultraviolet radiation. Center, visible light. Next, infrared radiation, microwave, radio wave. Now listen, listen very carefully. This is electromagnetic spectrum. In electromagnetic spectrum lamai, if you go from gamma rays to radio wave, this way, gamma rays to radio wave, gamma, X-ray, UV, visible, IR, micro, radio. This way, if you go, frequency of the waves will decrease. what will happen to the frequency? Decrease. Frequency decreases. Very high frequency, little low, 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 very low, very low, very, very low. So frequency will decrease. Very high, high, low, 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 very low, very, very low. What is frequency means? Last week work. Number of oscillations in a unit time. Simply, how many waves are there in 1 second? Frequency. This way decreases, this way decreases, this way decreases. Gamma rays have the highest frequency. Radio waves have the lowest frequency. If I draw and show you all, gamma rays, high frequency. See, in 1 second, lot of waves are there. Radio waves not like that. Radio waves not like that. Radio waves, see, in 1 second only this much waves. Here in 1 second lot of waves are there, frequency high. Here in 1 second only one wave is there, frequency low. Remember, from gamma rays to radio wave, frequency decreases. Frequency decreases. Meanwhile, wavelength will increase. Wavelength increase. Gamma rays to radio wave, wavelength increases. Wavelength increases kya? Gamma rays have the shortest wavelength. X-ray little more. UV more. Visible light more. Infrared more. Microwave more. Radio wave have the highest wavelength. Increase, increase, increase. Very high wavelength. If I draw and show gamma rays on. This is the wavelength. Radio wave. Very long wavelength. Very long wavelength. See? This is the wavelength. Can you see wavelength is increasing, increasing, increasing? Wavelength only this much. Wavelength this much. Wavelength increases. And that's the main reason why radio wave, microwave, even IR radiation, they are used to send signals to a long distance. They are used to send signal. Now, radio wave can be, you can send signal for very long distance because wavelength is long. Wavelength is long, long wavelength. So you can send signals, information, data for a long distance. Mobile phone communications, all are done by microwaves, radio waves. Telecommunication, television communication, radio waves. Why? Long wavelength. So long distance you can send. Now using gamma rays, can we send information? Wavelength is very short. You can't send information. Here you can send. Okay. So remember, wavelength will increase, frequency will decrease. Harini lamai. See. Look, see. We have an equation like this, no? V equal F lambda. We already learned speed of electromagnetic wave is 3 into 10 to the power 8 meters per second in vacuum. So in a certain medium, speed is constant. In vacuum, 3 into 10 to the power 8 meters per second. It won't change. So speed of electromagnetic wave is a constant. It won't change. It won't change. Now practically think, this is not changing. If frequency decreases, mathematically think, if frequency decreases, what should happen to the wavelength to keep this constant? Mathematically think. Frequency decreasing, then guaranteed what should happen to the wavelength to keep this constant? It should increase. One decreases now, the other should increase, then only it get balanced. That's how speed is constant. So frequency decreases, on the other side, wavelength increases. Frequency decreases, wavelength increases, and it gets balanced. Okay. හරිද? Okay. One more point regarding this visible light. ඔන්න පුතේ, visible light. Visible light is the light that is visible to our eye, white light. If you take white light consists of 7 colors. White light has 7 colors. What are the 7 colors in white light? Vib, GR. Vib, GR. What is Vib, GR? V for violet, I for indigo, D for blue, G for green, yellow, orange, red. Vib, GR. Violet, indigo, blue, green, or yellow, orange, red. Violet, indigo, blue, green, yellow, orange, red. This mixture is visible light. In both colors, VIBGR colors. If you look at this order, According to this order, violet to red. What is happening to the frequency? Frequency is decreasing. Same thing will happen. Same thing. This frequency decreases. Violet to red, frequency decreases. What happens to the wavelength? I'll write symbolically. What happens to the wavelength? Wavelength increases. So in violet, indigo, blue, green, yellow, orange, red also, frequency, there is a difference in the frequency. Violet to red, frequency decreases. Violet has the highest frequency. Less, very less. Red has the lowest frequency. Wavelength is increasing. Low wavelength, high, very high. So red has the longest wavelength. That is why you can easily detect red. From a very far away point, you can detect and see it. Its wavelength is very high. Out of the 7 colors, it has the longest wavelength. From a very far away distance, you can see red. And that's the main reason why red is used as danger symbol. Why? From a very far away distance, you can see. A traffic light. Why stop is red color? Because red, from a far distance, you can see when a driver is driving, from a far distance, more than yellow and green, you can see the red. I mean, lorries, if there is a huge load and that load is protruding out of the lorry, have you seen they tie a red color cloth? If the load is protruding out of the lorry, they tie a red color cloth. It's a must. It's like a rule. It's a must to tie red color cloth. Why? So for a person from far away distance can see. They can tie a white color shopping bag, no? Or they can tie a black color shopping bag, no? Red color shopping bag or color. That's because from a far away distance you can see. Even if you dress red on, people from far away can see you. People from far away can detect you. Right? That's the power that red has. That's the longest wavelength. On the other side, violet. Violet has the shortest wavelength. Okay. Yeah, even some animals get triggered for red color. You can trigger a bull using red color. That's another different story there. So remember that. Violet, indigo, blue, green, yellow, orange, red. This way, frequency decreases, wavelength increases. Again, one more time. Electromagnetic spectrum, gamma rays, X-ray, ultraviolet radiation, and then look at the order, right? Ultraviolet radiation, and then we go for violet. Violet, indigo, blue, green, yellow, orange, red. infrared radiation. See, nicely it's going. Red, infrared radiation, microwave, radio wave. Take a look at the electromagnetic spectrum. Gamma rays, X-rays, ultraviolet radiation, violet, indigo, blue, green, yellow, orange, red, infrared radiation, microwave, radio wave. Actually, ultraviolet means above violet. Ultra means above. Ultraviolet means above violet. Infra means below. Infrared radiation. Infrared means below red. Above violet is ultraviolet. Below red is infrared. That's how those names are given. Huh. Take your spectrum section, electromagnetic spectrum. Electromagnetic spectrum. A spectrum consisting of all possible frequencies and wavelength of electromagnetic wave is electromagnetic spectrum. Under that a box is given. I want you to draw this nicely. Draw. Use some color pens. Work. Once done, tell me done. Okay, no? Right. Now we have to go through each one of these waves separately. Gamma ray, X-ray, UV, visible, infrared. Each one of them, they are users and all. We'll have to go through separately. Starting off with gamma. Starting off with gamma. Gamma rays. Gamma rays, they have the highest frequency. Harini, you start the electromagnetic spectrum from gamma. They have the highest frequency and lowest wavelength. Highest frequency, lowest wavelength. Highest frequency, lowest wavelength. Highest frequency. Now, if you take gamma, gamma rays are emitted by radioactive elements. There are some elements called radioactive elements. Uranium, plutonium, radium, those are radioactive elements. They are very unstable. Their nucleus is unstable. Uranium, their nucleus is very unstable. Nucleus is unstable. As the nucleus is unstable, what will it do? It keeps on emitting energy. It keeps emitting on. This energy is emitted as gamma rays. This energy is emitted as gamma rays. Harini, rays, waves will transmit energy. They will propagate energy. So this energy is propagated, transmitted as gamma rays. So usually radioactive elements emit gamma rays, but harmful. Gamma rays are very, very harmful. It can kill living cells. It kills living cells. And you can't easily stop them. They easily penetrate through concretes. Through concrete, through thick concrete, they can penetrate. Through thick steel, they can penetrate. They can easily penetrate. Even these radioactive elements, you can't just keep it inside a cupboard. Now let's take plutonium. You can't just put it inside a cupboard and keep, just like keeping magnesium. Hey, through the cupboard, these gamma rays can come out. Cupboard can't stop the gamma rays. So it can come out. If it comes out, guaranteed it causes huge harm to us and all the living organisms around. It can kill the living cells. Usually when they are storing this radioactive element, they keep it under the soil, very deep under the soil, and cover it with several layers of concrete. Or they put it under the water, under the oceans, deep under the ocean, and again cover it with thick concrete sheet. That's how they store radioactive elements. Because always gamma rays are emitted from them. If I tell a usefulness, gamma rays is used for cancer treatment. Now it can kill the living cells, no? So using gamma rays, you can kill cancer cells. Now cancer cell is a harmful cell. So that cell you can kill using gamma rays. Okay. Uh, Take now gamma rays section. I want one of you to read. Who is going to read? Raise hand. Right, Saliha. Keep the hands risen. Don't put the hands down. So some more things are there to read. So one by one we can read. Right. First Salia raised the hand. Salia, you can unmute. Gamma rays. Right, Salia, you can unmute now.
Applications of electromagnetic waves, gamma rays, emitted by radioactive elements, highest frequency, have ability to penetrate thick sheets of steel, concrete slabs, used to destroy cancer cells, used to sterilize utensils used for food and surgical instruments.
Used to destroy cancer cell. Please underline or highlight it. It's a use. Used to sterilize utensils. Used for food and surgical instrument. What is this sterilizing utensils means? Specifically surgical. After a surgery is done, those instruments that are used for surgery will surely have germs. You can't use that same instrument for another person. Before you take it for another person, what they do is they sterilize that instrument. Sterilize that instrument means they put it in a chamber which has gamma rays. They put all these scissors and whatever the surgical instruments are there inside a chamber, there is gamma rays. What will these gamma rays do? Gamma rays will destroy all the living organisms. It will destroy germs, everything it will destroy. After all of that are destroyed, you can take it and use it again. Even some five-star hotels, the food serving utensils like knife or spoon, um, bowls, they all sterilized after cooking and after serving. About once when after one person eats and finishes with the spoon, that spoon sterilized using gamma rays to kill all the germs and any unnecessary things which are attached there. To kill it, they sterilize it. For that, they use gamma for sterilizing purpose. Okay. Next, going to gamma X-rays. Next, going to X-rays. I'll first explain how X-rays were discovered. Listen, how X-rays were discovered. Actually speaking, Lamai, X-rays were discovered by mistake. By mistake only X-rays were discovered. During discovery of atomic structure and subatomic particles, different scientists did different experiments to learn about subatomic particles and how they behave, about electron, about proton, about neutron. They did different experiments. During such experiment, what they did was they took electrons. When they were trying to learn about electrons, now you all know electrons are negatively charged. Their mass is 1,840 of the mass of proton. They are present in the energy level. Now you know. But initially some scientists should have discovered it. No? So during that discovery process, they did several experiments. So during one of that experiment, what they did was they took electrons. And they made a metal target. This is a metal target. It's a target. That's a metal target. They kept it in front of this electron. And then accelerated this electron to a very high speed. Accelerated the electron to a very high speed and bombarded those electrons on the metal target. Accelerated the electron to a very high speed and bombarded the electron at a very, very high speed. At a high speed, making this electron to get bombarded. Bombarded means colliding. Made that electron to go and collide, bombard on metal target. When it bombards, Lamai, when it collides, electron is coming with a very high speed. It has a high kinetic energy. All that kinetic energy should be stopped. All that kinetic energy should be stopped by the metal target. It's coming at a very high kinetic energy. Metal target should stop all those energy. During that time, a part of the kinetic energy, got converted into some other energy and got emitted as some unknown rays. A part of the kinetic energy got transferred into some other energy, and that energy was emitted as a certain wave. They never expected this. They never expected this kind of a conclusion. They never expected to get some other wave when they bombard the electron. They just wanted to bombard the electron and see about the mass of the electron. Can the electron penetrate? That's the experiment. So during that time, they bombarded the electron. When they bombarded the electron, some unknown rays are coming. Some unknown waves are coming. They didn't expect this. Kinetic energy is getting converted into some other form of energy and it's getting emitted as some unknown wave. You all tell me in maths, if something is unknown, what's the letter we use to denote it?
X.
X. We denote it using X. So these waves, they were some unknown waves, unknown rays. Therefore, they named it X-rays. That's how X-rays were discovered. Bombarded high-speed electron on a metal target, some unknown emitter, those unknown were called as rays. Now X-rays are used for so many different uses. Tell me the uses of X-rays. X-ray QM, what comes into your mind?
Can see the inner part of the body.
To scan the internal organs of the body. Neither. To take X-ray photograph, internal body organs, we use X-rays. What else? Now when you go to airport or any shopping complexes, right? There your baggages are scanned through a certain device. What is that device using? X-ray. Using X-rays, they scan your luggages without opening the light. If you look at the screen on that machine, in that screen, the X-ray photograph of your luggage is there. So whatever they are inside it, they X-ray scan it, see it without. So if there are any suspicious substances inside, so that's how they scan it. Without opening the baggage, they scan it. Even cargoes, they scan it without opening. If there are anything suspicious, then they open it and see. So for scanning also, they use X-rays. Okay. Who is next to read? Saliha read. Ilma.
X-rays generated by bombarding high-speed electrons on metal targets. A part of kinetic energy of electrons are converted to X-rays, used to take photographs of internal body organs of human body. X-rays travel easily through soft tissues and their intensity decreases when traveling through bones.
Once
Used
again.
to
Now X-rays, they can easily travel through soft tissues. Through your skin, through your soft muscles, it can travel. But can it travel through your bones? No. It is stopped by our bones. That is how internal photographs are taken. Bones, through the bones, X-ray can't travel. But through soft tissues, X-ray can travel.
used to examine baggage and cargo.
Used to examine baggages and cargo. Right. That's about X-ray. Next, going to ultraviolet radiation, UV rays. UV, ultraviolet. What do you mean by ultraviolet? Ultra means above. Above violet is ultraviolet. Frequency above violet is called ultraviolet. Frequency above violet is ultraviolet. Harinilamai, look at the spectrum. Look at the spectrum. According to the spectrum, ultraviolet is above violet. So above violet is ultraviolet. Can human eye see? No. We can only see visible light. No any other rays we can see. No any other electromagnetic waves we can see. Ultraviolet radiation, they are not visible to our naked eye. But some bees, they can detect ultraviolet radiation. Bees can detect. Now don't ask me, sir, how do you know that bees can detect ultraviolet radiation? That is by experiments you can find out. You put some bees in a certain experimental setup. You show ultraviolet radiation and see whether they show some response. If they show a response, that means they can detect UV. If they show a response, they do not detect UV. So bees, some bees are there, they can detect UV. They show some response to UV radiation. Mm, important point. um, Banknotes. Banknotes means normal notes, money note is there. Banknotes. In banknotes, there are some hidden symbols. In banknotes, there are some hidden symbols. With our naked eye, we can't see it. Normally, we can't see it. You expose the banknote to UV rays. When you expose to UV rays, then you can see those hidden symbols. So usually banks use this method to check whether the banknotes are original banknotes or whether it's duplicated. Why? If it is duplicated, those hidden symbols cannot be, no. So banks used to check whether money original bank or is it duplicate using method. There are some symbol, they will only be visible under UV rays. As well as there are some chemicals that glow when there is UV. There are some chemicals that glow when there is UV. Those chemicals are included in some detergents. Now, there is something called comfort, which we put for the dress. There is something called comfort. In comfort, we have those chemicals. When you put comfort to your dress, now it glows very well. Neither. Why? In comfort, you have those chemicals. When you put it to your dress and wash it, and when you go under the sun, you have UV. Sunlight has a little amount of UV. So that UV, when it falls on your dress will glow. That's how that comfort, they make the dress glow. Not only comfort, nowadays some detergents also, they include that chemical in it. So once when you wash the cloth with chemical and go into the sun due to UV, that cloth will glow, will glitter. Okay. Morning sunlight is good. Why? Why sunlight is good? Morning sunlight, it's not very strong, and you can get UV, enough UV. When that UV radiation falls on your skin, in our skin we have a chemical that makes vitamin D using UV. So our skin has a chemical that can produce, that can make vitamin D using UV. So that's why people tell sun gives us vitamin D. No, sun doesn't give us vitamin D. Sun gives us UV. That UV, when it falls on our skin will synthesize, our skin will make vitamin D. Okay. Those are the important points. Who is there to read? Izan Alim.
Ultraviolet radiation (UV rays) have a frequency range above violet, not detectable by human eye, but insects such as bees can detect UV. Sunlight has little amount of UV, also released from electric discharge and mercury vapor lamp.
One second. Sunlight has little amount of UV. It's also released from electric discharge. During lightning, big electric discharge will happen. During that time, UV is released. Even mercury vapor lamp, it also releases UV.
Produce vitamin D in human body, used in hospitals to kill germs, used to check banknotes, used in washing powders to make clothes glow.
Used to check banknotes, used in washing powders, used in hospitals to kill germs. You can kill germs using UV. Right. Next, going to visible light. Visible light. Visible light is the electromagnetic wave that is visible to our naked eye. Contains 7 colors. Can remember 7 colors, no? With your colors. Okay. Who's going to read? Nehenza.
Visible rays. Human eyes are sensitive. The frequencies of the visible light range from 4.28 into 10 to the power 14 Hz to 7.69 to 10 to the power 14 Hz, corresponding to a wavelength from 619 to 14. Has 7 colors: violet, indigo, blue, green, yellow, orange, and red.
Orange. These frequencies and wavelength no need to memorize. But just know that these are the frequency range: 4.28 into 10 to the power 14 Hertz, 7.69 into 10 to the power 14 Hertz. Wavelength is 690 nanometers to 400 nanometer. NM means nanometers. NM is nanometers. Nanometer. That's a wavelength. IR, infrared radiation. Infrared radiation. Huh. Infrared radiation. Frequency below red. Infrared radiation. Infra means below. Ultra means above. Infra means below. So infrared radiation means infrared. Below red. Frequency below red is IR. Again, not visible to human eye. There's another name for IR. There's another name for infrared radiation. You also call it heat waves. You call it heat waves. Why heat waves? That is because heated bodies emit IR radiation. Heated bodies emit IR radiation. Best example, we, human. Our body temperature is 37 degrees Celsius. 36.9, 37 degrees Celsius. So compared to the environment, we are a hot body. So we emit heat rays. You can take a heat photograph. There are thermal cameras. Using thermal cameras, you can take heat photograph. If you take a heat photograph of your palm, this region will be red in color. These regions will be red in color to show that those places are very hot. After that, somewhere inside, this region will be orange in color. This region will be orange in color to show that there the temperature is slightly less. After that, somewhere inside, this region will be yellow color. Temperatures are more or less. Most of the time, center point will be somewhat bluish color. Blue, green, and all shows that temperature is very, very less. So you can take a heat photograph and see. Okay. Even this is used in military purposes. There are some special binoculars in which you can detect IR radiation. IR radiation means heat waves. Now, when military goes for any special missions, before they enter that place, they'll first look with the binocular. Now, maybe just when they see, they can't see any people. When you use a binocular, when you use a heat wave binocular and observe, if there are any people standing there, you can see them in red color. Why? Compared to the environment, we are hot bodies. We emit heat waves. So red color we can see. So if there are any humans standing, we can see it in red color. If you have played IGI Mark III game, anybody have played IGI Mark III game?
Yes, sir.
In
Yes,
IGI
sir.
Mark III, there's a special binocular. When you put that binocular, you can see. It shows soldiers in red color. Right? So it's mainly used for this thing. I don't know whether PUBG has it. I have not played PUBG. I don't know. Right. So, however, IJ Mark III, it has this. Now, don't start downloading IJ Mark III and play it. Here there is a game. In that, you have a binocular in which you can see people in red color. Okay. So, that is a binocular. Huh. IR radiation, it is used for short distance communication. Very short distance communication, IR radiation can be used. Short distance communication means usually used in remotes, TV remotes. TV remote to TV, very short distance. No? So you give signals from TV remote to the TV using IR radiation. Have you seen in the remote, in front there's a small LED bulb. That LED bulb will emit IR radiation. I have a remote here. In front, this LED bulb here, it emits IR radiation. And that's why however much you press it, you never see it working. No? Why? It's emitting IR. Is IR visible to the naked eye? No. But it is visible to the camera. Through cameras, you can detect IR radiation. Now this one, if I just see, I can't see anything working. I'll show it to the camera and see. We can see. Wait, I'll show that. I'll make the place dark. Can see, no? Hurry. On. This is the remote. I'll press and show you all. See whether you all can see a purple or reddish color light. Can you see? I'm pressing it. I'm continuously pressing it.
Yes, sir.
Can you see?
Yes, sir.
Yes,
That is
sir.
IR radiation. See? Cameras can detect. Naked eye can't. Okay. Is there someone behind you? What is he? Don't make me scared. No one is there. It's only me. This is also nice, no? If we do the class. Hi.
Yeah, sir.
This is also nice.
Yes,
New,
sir. Hello, sir.
new style class. IR radiation. IR radiation. Maru ini shadow teaching on the new style. Shadow teaching. Shadow teaching. PDF?
Shadow teaching by Kingsbury.
There's a within black man. Hari hari hati hati. So that is IR radiation. Even night vision cameras, they use IR radiation. Some CCTV cameras, they use IR radiation for night vision. Okay. Who is that? Read. Adeyappa, how shall I tell your name? Can you rename? Wait, I'll allow rename. Rename. You rename, I'll give to the next person. Zuha. Wait a
In
minute. So wait. Lena is there. She has renamed, I guess. We'll give to Lena and then go to Suva. Okay. Right. Lena.
A range of frequency below red, not sensitive to human eye, emitted by heated body, heat rays, can take heat photographs to identify certain diseases, used in TV remotes, used for
Physiotherapy.
psychotherapy treatment.
Treatment. So you can take heat photograph and identify certain disease. There's a special treatment called as physiotherapy treatment. For physiotherapy treatment also they use IR radiation. IR radiation. After IR, next what? Micro. Micro. Microwave. What are the uses? Number one, used in radar technology. Radar technology. I'll talk about radar separately. Radar. Next, mobile phone communication. Mobile phone communication. Wavelength is long. Mobile phone communication. And in microwave oven. In microwave oven. Microwaves are used. First, I'll talk about microwave oven. What is the mechanism in microwave oven? Remember, microwave oven is not like the normal oven, not like baking oven. Baking oven mechanism is totally different. Microwave oven, it's only used for short time heating. Short heating. So microwave oven, what's the working mechanism? If you take a microwave oven, inside the oven, let's take Maggi noodles is there. This is Maggi noodles. You are going to heat it. Inside this microwave oven, you have a special device called magnetron. Open the mouth and tell. Magnetron. A device called magnetron. Magnetron will only emit microwaves. It has the ability to emit microwave. Somewhere here, you have a fan. Now, this is what is going to happen. Magnetron will emit microwave. It emits microwave. That microwave is spreaded around by the fan. Fan will spread the microwave around. Around microwave is spreaded. When microwave falls on the food, now listen very carefully. When microwave falls on the food, in the food you will have water and fat. Any food you take, there will be at least a little amount of water, or there will be fat, or there will be both of them together. Water and fat. Fat is lipids. Oils will be there. Gas, there will be water and oil, or both of them. That some of that will be surely there in the food. When microwave falls on water or oil, what will happen? This water or oil will start vibrating. It starts vibrating. Water molecule starts vibrating. Oil molecule start vibrating. Now think. This is a water molecule. This is a water molecule. They are vibrating. When they are vibrating, they rub against each other. Y'all tell me, when two things are rubbed against each other, what is generated?
Charges, electric
Electric charge.
Heat,
Charge is generated.
Electric
No,
charges.
not electromagnetic.
Electric
Wait.
electric
Heat. That's the answer I wanted. When two things are rubbed like this continuously, what is generated? Heat is generated. So when microwave falls on water or oil, their vibrational kinetic energy will increase. Therefore, those molecules will rub against each other. When they rub against each other, heat will be generated. That is how food gets heated. Basically, that heat is produced. Within the food. Inside the food itself, heat is generated. We are not supplying heat from outside. Inside the food itself, we are rubbing and producing the heat. That is why after you heat the food in microwave oven, have you seen? Food is hot. Not hot. I will come across it. Food is very hot. But whatever the vessel you keep, it's not that hot. Why? Heat is generated within the vessel, within the food. Inside the food itself, it is generated. Not from outside. Not from outside. That's speciality in a microwave oven. Okay. So that's the use of microwave. Other than that, mobile phone communication. Now when you make a call from your phone to the nearby tower, signal is sent by microwave. Phone to the tower, signal sent by microwave. So mobile phone communication, microwaves are used. Radar. What is this radar? It's a communication system made for the communication between aeroplanes and control centers. Now, when an aeroplane is flying, each and every, after every 10 or 15 minutes, I don't know the exact timing, after a certain time, pilot have to update the ground center, control center, regarding the speed of the flight, altitude, wind speed, direction, all those information they have to keep on updating. This update is given using microwave. From flight to the control center, update is given using microwave. They don't make a call. There's no call or anything. Directly from the flight, in the flight you have a magnetron. That magnetron will produce microwave. From that microwave, only signal is sent to the control center. From that control center, will get to know where the flight is. Is the flight position exactly correct? Now, they will be tracking through GPS as well as they will cross check with the pilot as well to check whether is there any malfunctions in the flight. Now, let's say pilot is telling altitude according to the meter here is 13,000 feet. Altitude according to the meter is 13,000 feet. But in the ground center, the altitude that they are getting from the GPS is 20,000 feet. That means they know there is an issue. Pilot is updating only 13,000 feet. GPS is updating 20,000 feet. There's an issue. There's a malfunction. Maybe they'll update the pilot and pilot will announce Mayday. They will land the flight as soon as possible. Okay. So for this, always this communication between the pilot and the ground center is important. That communication is done using microwave. And have you heard, now if you have gone in the flight, they tell you to switch off the phones. Some fellows doesn't switch off. Why they tell to switch off the phone? From the phones also, what wave is emitted? Microwave. That microwave can interrupt the communication between the pilot and the ground center. Your microwave from the phone can interrupt the microwave from the pilot to the control center, to the ground center. That is why they tell to switch off the phones. There should be no any microwave interruptions within the flight. Then they can make proper communication between the flight and the control center. That system is called as radar system. Radar system. Huh. Come to microwave. Who is there to read? Deluction.
Microwaves used in radar system, mobile telephones, and microwave ovens. Water and fat in food have the ability to absorb microwaves and convert that energy into vibrational kinetic energy, heat. This is the principle behind the operation of microwave ovens. An instrument known as the magnetron is used to produce microwaves in microwave ovens and radar systems that need high power microwaves for their operations.
Right. Thank you. Next, finally, radio wave. Used for what? Very long distance communication. For long distance communication, radio waves are used. Between a signal tower and a satellite, for that communication, radio waves are used. Now, TV channels are transmitted using radio waves. For that, antennas are used for receiving. Radio frequency oscillator scale, there is a device. Radio frequency oscillator will emit radio wave. Antennas will receive radio wave. So TV communication is done using radio waves. Even now, the Zoom, here the communication is done using radio wave. How? When I'm talking, my what I'm talking, whatever my these things data is collected, that data is transmitted through internet. That internet will connect the closest nearby satellite, closest nearby tower, closest nearby tower. From that tower, our data center is, now in Zoom, it shows your data center. Can you see, if you all click that green color icon at the bottom, they tell you are connected to Zoom global network via data centers in India. So our data center is India. So my signal is, now I'm the transmitter. No? My signal is first transmitted to the nearby tower. That tower data is sent to the satellite that is there in the space. It goes to the space. See, now when I'm talking, I go to the space and come. My signal is sent to the space. From the tower to the space, from the tower to the satellite, that communication is done using radio wave. Again, that satellite will send the signal back again to the data center in India. That communication also radio wave. From there only distributed to my viewers globally. That's how distribution is done. So that long distance communication is done using what? Radio waves. Everything in a millisecond. And TV channels, they work like that. From radio frequency oscillator, directly the signals are sent to the satellites by radio waves. From the satellite, it again comes back into your antennas, again using radio waves. Antennas will directly receive it. That's a full communication done. So very long distance communication, radio waves are used. Who is there? Zuha.
Radio waves, used for long distance communication, produced radio frequency oscillators and received by antennas.
Received by antennas. Ta-da! Electromagnetic waves done. Yep. Thanks to all those who read. Any doubts? So how are you? That's the doubt. I'm fine. Any doubts from this section? Clear the all clear, no? All of you all join the WhatsApp group and stay. Now, those who asked how to continue the permanent class, I will update in the WhatsApp group, right? I'll update in the WhatsApp group how things are going to work, right? This is the time slot continuously for your interactive class. Now we all know how this interactive class proceeds. It's unmuting, you talk, me talk. That's how the class proceeds, right? Now, initially some people are unmuting and talking. Later on, everyone, I want everyone to unmute and talk. So slowly it become more and more interactive. So that's the main idea of this class. So slowly later on, this will be more integrated. More systems will be updated into this, right? There are plans are also there. So continuously until your O-level exam, this is the time slot, 8 o'clock to 10:30. Then 10:30 don't tell Anisa sleepy. Even my cat, that fellow sleeps at somewhere around 12 o'clock. Right? No, y'all should work. Now y'all are the batch. Only y'all are the batch, eh? The previous batch has gone. They are gone now. Their exam is done. So they will focus on their future studies. Now our batch name comes to all. Y'all are the batch. Now every hard work, everything should start from your end. This is your 11th year in your education. So first important public exam is coming. So you can't just normally do it in a normal term test or a unit test way. So from your end, there should be a hard work given. Sometimes you have to sacrifice things. You have to sacrifice sleep. You have to sacrifice happiness. You have to sacrifice sometimes your friends. Sacrifice some important work. Sacrifice, so many sacrifices are there. You have to do. So now you have to remain little. You have to wake up a little longer and remain. Our Singiti life is gone. Fairy tale life is gone now. Slowly you have to shift into your hard working life now. All right. Don't worry, from my end, my fullest will be given. Fullest can anything 100, 200 percentage will be given. Even last year, those who have followed with me, they know how much we have done for the last year. Just go to the YouTube channel and see how much is done for the last year batch. Until the last day that the government told to stop everything, such a huge work was done. So double that work is already planned for you all. So from my end, I am ready to give my 100, maybe 200, maybe my fullest maximum. From your side, I need 1,000, 2,000 time of your maximum. Then only this will work out. So from now itself start working. Don't wait until the last day. Don't wait until that last 3 months, last 6 months. No. Today is the day. Now we itself start working. Every week allocate minimum 3 hours for your science. Each check like that. Minimum 3 hours for that certain subject. Why? Whatever we do in the class, you have to do it. Additionally, other than that, you have to start doing past papers as well. So, you have some more things. So, whatever we do in the class, now already 2 classes are done. Whatever we do in the class, you have to revise. You have to learn it back again. Now, which you have to lock it in your mind. You can't keep allocating things. If you allocate in a way, you can't start accumulating things. If you're accumulating things only, at the end it becomes a big stress. So don't allow that to happen. Stress can happen if you accumulate things. So you know the reason for the stress. So don't allow that to happen. Now, how to avoid it? Every week, whatever we do in the class, that week itself you revise, you put it to the mind and you finish it. Or this week, 7 days are there. What can't you do? So whatever we did during this week, only small sections there. Memorizing part, memorize and put it. Studying part, study and put it. Logical part, logically put it to the mind. And do papers. It's right. And already in grade 10, if you have not touched the grade 10 books properly, 2 books are already waiting for you. Start covering that as well. Don't wait until the last moment to cover. Hurry now. For today, I'll finish off with that.
Thank you,
Be
sir.
in the. I'll come to the doubts. Be in the WhatsApp groups. If there are any questions and everything, I'll put it to the WhatsApp group. Additional points and everything, I'll put it to the WhatsApp group. So with that, our interactive free classes will finish off. From next month onwards, we are shifting to the normal permanent paid class. About that, all the details, me or my admin will update in the WhatsApp group. Okay. I'll stop the WhatsApp. I'll stop the live. After that, y'all can talk if anyone wanted to talk.